ball is dropped from a height of 10 feet. It bounces 80% of its previous height each time. Find the total distance that the ball will have traveled. So let's talk for a second about what is happening in this example and why this falls under the chapter that we're in. So the first time the ball drops down here, it has traveled, what did it say? It dropped 10 feet the first time. So there's our 10 feet. Well, the ball drops and then it bounces up 80% of its previous height. So it's going to bounce up about this far, let's say. So it's going to bounce up. 80% of that height of 10 feet actually is 8 feet. Well, if it bounced up 8 feet, that means it also has to bounce down 8 feet. And then if we go 80% of that, 80% of this height right here, well, we bounce down and we bounce up to about 80%, which looks about right there. So 80% of the 8 feet is 6.4 feet. So it went down 6.4 feet and it went up 6.4 feet. I'm doing that in the backwards order. First it went up 6.4 feet. And then it went down 6.4 feet. So this pattern can continue. You know, it bounces down, then up 80%. So we have 5.12 both ways. So what does this have to do with anything we've been learning? Well, if you are going from, you know, if we consider these to be terms, you know, this is a term, this is a term, this is a term, how are you getting from one term to the next term? And you actually are multiplying by that 80% or by that 0.8. And then you're going to multiply by 80% again, which is 0.8. And this does turn into a geometric sequence because to get from one term to the next term, you are multiplying by 0.8. So it's geometric. Now, what we have to ask ourselves is how long is the ball going to keep doing this? You know, it's going to keep bouncing and bouncing and bouncing and bouncing. You know, we do have this thing called gravity that will eventually keep it from bouncing and will bring it to a stop. But without gravity, could we always go 80% of the previous bounce? And you actually can. So that's what makes this an infinite geometric series. Because without gravity, this ball could bounce forever. It may bounce like 0.0002 inches or centimeters, but it still mathematically can happen. So if we want to know the total distance, we want to add all these up. We want to add up the 10 feet and the 8 feet and the 8 feet and the 6.4 and the 6.4. So because we want to add all of these up, we're looking for the sum of the infinite geometric series. We have a formula for that, which is a sub 1 divided by 1 minus r. Now, the ratio, what are we multiplying by each time, actually is going to be 80%, or I'll just write it as the decimal 0.8. Now, where this gets a little bit tricky is figuring out that first term. Now, if you notice, we have a pattern of things, you know, bouncing up and down, up, down, and this is going to continue forever. The one thing that kind of stands alone is this first drop, because we're starting at a height of 10 feet. So we're going to ignore that first drop, because the geometric series actually doesn't start until this bounce right here. So our first bounce, full bounce, you know, coming up and going down, is going to be this one, which is a total of 16 feet. So 16 over 1 minus 0.8 gives us 80 when we do that math. So what we're finding is that from here all the way out is 80 feet. And we want the total distance that the ball traveled. So we do still have this initial drop of 10 feet that we have to consider. So it drops 10 feet, and then it does the geometric series, the infinite geometric series of 80 feet. So we're going to add those two numbers together to get 10 plus 80. This ball is going to travel a total of 90 feet. So what we want to remember is that the infinite geometric series does not start until the ball does a complete bounce up and come down. So we have to add on that first initial drop in the end to get the total distance the ball travels.